Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. This is the fourth chapter in the series. We already discussed about many interesting concepts like runtime, SDK, projects, solutions, namespaces, and classes. In this chapter, we are going to discuss about variables and data types. Let's first understand why do we need variables. Any software program is basically a collection of step-by-step instructions. Each instruction performs some operation on input values. Some instructions may produce intermediate values, and then there are some other instructions which perform some other operations on intermediate values, and ultimately this step-by-step execution produces the desired outcome. All the inputs and intermediate values are stored in the computer memory. The instructions in your program are supposed to access this data. One way to access the data is program should always know the exact memory addresses of each and every value that is required for processing. Even if we think that this may be possible, there are few problems. If we run the same program multiple times on the same machine, there is no guarantee that the memory addresses allocated for the program would be same. Also, the memory addresses available on one computer may differ from those on other computer. One computer may have more memory while the other computer may have lesser memory. Just to give you idea about how difficult it would be to handle memory addresses, let's take a real world example. Every place on the earth can be identified by using latitudes and longitudes. But it would not be very easy to understand if someone uses those values in our day-to-day conversations. Likewise, it would be very difficult and time-consuming to program if you want to handle actual memory addresses in your code. That's where the concept of variables comes handy. A variable allows you to access the data stored in the memory. The program then doesn't need to worry about memory allocations and addresses. Compilers and runtime will take care of handling all those low-level tasks. Our code can just declare the variables with appropriate name and then use those variables wherever required. Note that variables must be declared before using them. Let's say we are working on a calculator application. The calculator allows to perform any one of the four mathematical operations which are add, subtract, multiply, and divide. Let's say application asks user to enter two numbers and then user can also select the operation that should be performed. So inside our code we can declare two variables, one for each user input, and then those two variables can be used for performing mathematical operation. Now let's see how to declare a variable. Generally, a variable declaration in C# starts with a data type followed by the name of variable. The name of variable can contain letters, digits, or underscores. A variable name can start with either a letter or an underscore. Okay, let's move to data type now. A data type basically decides what kind of values can be stored in the variable. For example, there are few data types which allow only numbers to be stored. Data type also sometimes decides minimum and maximum values allowed in the numeric variables. Data type also decides whether a single value of the given type is allowed or whether the variable can also store multiple values of the given type. Compilers must always know the data type during the compilation. C# is a strongly typed language. Now what is the meaning of strongly typed language? Every variable must have type. Also, this data type cannot change during runtime. If you try to assign the values which are not allowed, then the program will get compilation errors. Compiler would fail to compile the program. For example, if you declare a variable to be numeric, then you cannot assign a boolean value true or false to it. Compiler will throw errors saying that this is not allowed. We have seen how to declare a variable. Now, one more concept before we dive into the code. C# provides a lot of built-in data types. You can define variables to hold the numbers, alphabets, or sequence of alphabets, etc. In addition to built-in data types, C# also provides a way to create your own data type by using structures, classes, and records. In this chapter, we are going to cover only built-in data types. We will cover structures, classes, and records in some future chapters. There are two more concepts that we all should know. All the data types in C# can be broadly classified into two categories: value types and reference types. Let's start with value types. A value type variable is a variable which directly holds the values at the assigned memory location. A value type also has one characteristic. Regardless of the value it contains, a value type always takes fixed number of bytes in memory. For example, a numeric data type integer will always take 4 bytes in C#. A character data type would always take 2 bytes. When the variables are allocated in memory, there is one more important thing. The program memory is generally divided into two main areas: stack and heap. The value types are stored on stack. Some very common value types are integer, long, character, and boolean. Okay, now let's look at the reference types. A reference type variable does not directly store the value, but it stores the reference to the memory location where the actual value is present. So the reference type variable is like a pointer. Another characteristic of a reference type variable is its size generally is not fixed. The actual size depends on how much data is present. For example, the string hello world would need lesser memory space than, let's say, hello world again, as it contains less number of characters. Also, the reference type values are stored on heap. As the diagram shows, the actual object is created inside the heap. The reference to that object is on the stack. So the program needs to make an additional jump to another location inside heap to read its value. Some very common reference types are string and object. We can also define our own reference types by using the keyword class. Since we are talking about the reference types, let's also talk about a special value, null. A null is a special value for all the reference type variables, and it means that the reference type variable is not pointing to any value. Null can be assigned to reference type variables, but null cannot be assigned to the value types. Okay, we have discussed enough about data types and variables. It's time now to get our hands dirty and declare some variables in the code. Let's open the Visual Studio. Let's create a new console application. The .NET 6 console application template does not contain main method, but as we are learning C#, my recommendation is to keep everything explicit so that we understand each and every bit of what is happening. So I am going to disable the implicit usings. Then I am deleting the default code from program.cs. And now let's add the main method which prints hello world. Okay, we are there. Now we will try to declare variables in code. We will also try to cover some basic operations allowed for each data type. Let's start with string. String is a reference type. Anything inside double quotes can be considered as a string. For example, in our program, we can create a new variable to hold the string hello world. The equal to sign here is called as assignment operator. The variable which you want to initialize should be on the left side of this equal to sign. The value that we want to assign should be on the right side of this assignment operator. Okay, the variable is declared now, and we can use this variable inside console.writeLine to print the value. A string can contain each and every character, including brackets, hyphens, currency symbols, digits, and even quotes. For example, here we declare another string variable which contains all the special characters, including curly brackets, square brackets, hyphens, plus operator, everything. Double quotes mark start and end of a string. So if you want to include a double quote inside a string, then you need to escape it with a backslash. Let's create a variable which contains a double quotes. Note that backslash is not going to be part of the string. Also, string variable may contain only digits, but that does not mean that you can perform mathematical operations on that string variable. If the digits are inside double quotes, they are considered to be text, and mathematical operations are only allowed on numeric data types. One more thing, a string can also be an empty string. It may not contain any character, simply starting double quote and ending double quotes, or you can use string.empty. Note that C# considers white space as a character. So if you declare a string which contains white space, it is not considered as empty string. Every time you change the value of a string variable, a new object is getting created on the heap, and the reference to that object is stored in the string variable. The number of bytes taken by string depends on the number of characters present in the string. Every character takes 2 bytes in .NET. So total bytes occupied by the string is equal to 2 multiplied by the length of that string. You can get the length of any string by using .length property. Common operation for string is concatenation. It's easy. Just use a plus operator. It will combine the two strings into one. And after using plus operator, do not forget to use assignment operator to store the combined value. As this is the only reference type that we are going to cover today, let's try to assign null to a string. We can just create a new variable of type string and then initialize it with null like this. Note that this produces a warning, but currently we are going to ignore it. Also, some variables are grayed out because we just have declared them, but we are not using them for any operation. For each such variable, a warning is generated by compiler, suggesting either to use the variable or to remove it completely. This warning makes sense, but as this chapter is only about declaring variables, we are going to ignore this warning. Okay, let's move on to the next type. Let's look at the character type now. It is a value type. In computer world, characters are internally integers. You might have seen ASCII map of characters where each number actually maps to some character. In .NET, Unicode characters are supported. This means that a character is internally 16-bit integer value, and every integer value represents a single character from Unicode character set. A character value should always be inside single quotes. Note that it is a value type and hence we cannot assign null to it. Note that empty values are also not supported for characters. You must specify a character within single quotes. Also, unlike string, plus operator would not combine two characters. It would perform addition of the two integer values. Let's move on to the next type. Next, we are going to have a look at Boolean data type. It is the simplest value type. If you declare a variable of type Boolean, its value can either be true or false. C# provides bool keyword for Boolean type. True and false are also C# keywords. They can be used to set the Boolean type value. Generally, every C# keyword is highlighted in blue. In C#, a keyword is a word that carries some special meaning. For example, bool is a keyword that is used to declare variables of Boolean type. String is a keyword which is used to define variables of string type. True and false are also keywords which can be used to specify values. Common operation on Boolean type is negation. The exclamation mark negates a Boolean value. For example, let's declare a variable of type Boolean. Its name is product free, which is to tell whether the product is free or not. And let's say we also declare another Boolean variable has price, which needs to be true if the product is not free. In that case, we can simply use negation, that is the exclamation mark followed by product free, the variable. Even if we do not assign any value to a variable, the variable gets initialized with some default values. If you want to check the default value of a data type, you can use the default keyword. For example, let's check what is the default value of Boolean type. So if I declare a new variable and initialize it with default of bool, and if I run the application, then I can see that the default value of Boolean is false. Okay, let's move on to the next type. Okay, let's talk about numeric types. Numeric types can be broadly classified into two areas: the types which supports number with decimal points and the type which does not support decimal point numbers. Let's start with the types which do not support decimal point numbers. There are four such types: sbyte, short, int, and long. Sbyte occupies 1 byte in the memory, short occupies 2 bytes, int occupies 4 bytes, and long occupies 8 bytes. More the number of bytes, more is the range of possible values which can be assigned to the numeric type. You can find minimum and maximum possible value of any of these types by using max value and min value properties. For example, let's declare a variable of type long, and to check what is the maximum possible value for this variable, we can print long.max value. Similarly, for knowing the minimum value for long, we can try to print long.min value. These four types support negative numbers as well as positive numbers. If your input area does not include negative numbers, then you can also choose unsigned types. These unsigned types do not support negative numbers, and those types are byte, ushort, uint, ulong. The first letter U stands for unsigned. Now let's talk about the numbers with decimal points. There are three data types that are provided by C#: float, double, and decimal. Float occupies 4 bytes, double occupies 8 bytes, and decimal occupies 16 bytes. These three types differ only in the precision they offer. Precision means how many digits after decimal points can be stored without automatically rounding the number. Float offers precision of approximately 7 digits after the decimal point. Double offers precision of around 15 digits after decimal point. Decimal data type offers highest precision of around 29 digits. If you want to initialize a variable of float type, then the value should be suffixed with letter F as shown here. If you want to initialize a variable of double type, then no suffix is required. And for initializing value of decimal type, the number should be suffixed with letter M. Generally, decimal type should be used where highest accuracy is required. For example, financial calculations need exact accuracy. Even small rounding may cause errors in the calculations. Minimizing memory requirements for a program may be one of the reasons of choosing double and float over decimal. Also, you can use double when optimization for performance is more important than accuracy. Now, as we know, numeric types support mathematical operations, and common mathematical operations that are supported by numeric types are addition, subtraction, multiplication, and division. For addition, we can use plus character. For adding two numbers. For subtraction, we can use hyphen, that is minus sign. For multiplication, we can use asterisk, and for division, we can use a backslash. If all the numbers involved in a mathematical operation share the same type, then the result would also have the same data type. If the numbers involved in a mathematical operation have different types, then the result will have type of an input which had a larger size. For example, addition of int and long type variable would return a result of type long. If one of the input in mathematical operation is a number with decimal points, then the number with decimal point would be returned. For example, addition of int and double would return a double. Okay, let's move on. Till now, we have covered string, character, boolean, and numeric types. Now let's have a look at how to handle date and time values. C# provides a type datetime, which is a struct. A struct is always treated as a value type, and hence datetime is also a value type. You cannot assign null to a datetime variable. As the name suggests, a variable of this type contains both date and time values of a moment. For example, we can declare a datetime variable and we can initialize it with datetime.now. Datetime.now provides the value of today's date and current local time, the time at which this line of code was executed. Datetime.utcNow provides current UTC date and time. You can also declare a datetime variable using specific date and time values. For example, we can create a new variable of type datetime and then specify a new keyword followed by the name of type, and then in brackets we can specify 3 numbers for year, month and day. Optionally, we can also specify 3 additional numbers for hours, minutes and seconds. The new keyword that we have used here is used to create the instance of datetime struct. We will try to cover this keyword when we discuss more about creating custom types using structs, classes and records. Sometimes, instead of exact date and time, you may just want to store a specific date value. For example, you may want to store date of birth for your customers, and so that your application can send them emails about special offers. Or for some applications, dates are not important at all. For example, when you are working on an application for setting daily reminders, you may not be really interested in the date part. For handling such data, .NET 6 introduced 2 new types, date only and time only. These types can be used for such purposes. Date only, as the name suggests, holds only date value, and time only holds only time value. Like date time, both date only and time only are structs, so they are also value types. We cannot assign nulls to variables of those types. For creating date only variable, we can use new keyword followed by the type name, and then inside the brackets we can specify 3 numbers specifying year, month and a day of a date respectively. For creating time only variables, the syntax is similar. We need to use the new keyword followed by the type name, and then inside the brackets we can specify 3 numbers, and those 3 numbers are for hour, minutes and seconds. Okay, now let's say we declare 2 variables of type time only, and now we want to find out the difference between those 2 variables. For this purpose, we can use minus operator. The result of this operation will not have time only type. The data type of the result is time span. The time span is another struct provided by C#. It is also a value type. If we want to declare a variable of time span type, then it is exactly same as declaring a time only variable. We need to specify the new operator followed by the type name, and then inside the brackets we can specify hours, minutes and seconds. Although time only and time span declaration is similar, semantically they carry different meanings. Time only is to hold a specific time of the day, while time span is to store the interval between 2 time instances. For example, let's say we declare a time only variable which holds value of 1 PM, and then we create another time only variable which holds value of 5 PM. Now, if we calculate the difference between these 2 time only values, the resulting time span will contain 4 hours. Let's move on to the final topic of the discussion. Till now, when we declared variables of any type, we explicitly specified the data type. But there is one more way. Instead of specifying data type before the variable name, we can also specify var. Var is a keyword in C#. A var is permitted only if you are initializing the variable on the same line with some value. So a variable declaration like var x equal to 10 or var y equal to, in double quotes, hello is perfectly fine, but var z is not going to work. It will result in compile time error. In some languages like JavaScript, var is used to declare variables, and then any type of value can be assigned to the var. So for some time, same variable can hold integer value, and then after some time, the same variable can hold, let's say, a string value. This type of languages are called as dynamically typed languages. But C# is strongly typed language. Compiler should know the type of a variable at the compile time and it cannot change during runtime. A variable of a type can only hold a value of that type. So how does compiler knows the type when a var is used instead of data type? In most of the cases, when we assign a value to a variable, the expression on the right side of the assignment operator is evaluated. The evaluated value also has a type. During the compile time, compiler tries to understand the type that would be resulting after evaluating the right side expression. And then the compiler tries to look at the variable's data type. If the variable's data type is specified explicitly, then compiler ensures that it matches with the data type of the value of right side expression. If they are same, then there are no errors. If var is used instead of explicit data type, then compiler replaces var with explicit data type that was derived from the evaluation of right side expression. So when we specify var x equal to in double quotes text, compiler replaces var with a string. When we specify var span equal to new time span, compiler detects that the type on the right hand side is time span and therefore it produces the compiled code to use the explicit type time span. And if you declare var temp and you don't specify the value, then the compiler is not able to figure out the explicit type that should be assigned to temp, and thus compiler throws an error suggesting to specify data type for the temp. So the compiled code would never contain var. Bottom line is, var is just a syntactical sugar added to save some keystrokes for developers. It also helps in making the code easy to read in some cases. If you have used var and compiler is not able to figure out the right data type, then your code may get compile time error suggesting to specify the type explicitly. We have covered many concepts now, and I think you should have good understanding of the basics. Below are some exercises that you can try. Exercise 1, declare few variables and then try to print their values. Exercise 2, declare various numeric type variables and try to perform some arithmetic operations. Exercise 3, declare a variable of decimal type and another variable of double type and then try to perform some arithmetic operations. This might be a little tricky. Exercise 4, perform subtraction on two time-only variables and print the result. Try these exercises and let me know how it goes. Thank you for watching this video. Please do not forget to like and subscribe to this channel. Your likes and subscribes will motivate me to bring the next chapter sooner. If you have any feedback or suggestion, or if you want me to cover any specific area, please comment on this video. Alright guys, see you in the next chapter. Namaste.